Hello, ladies and gentlemen. I'm happy to announce that Ivan, let me a second, that Ivan Fraixedes is
Right. Yeah.
joining, is a seasoned software developer from Storj Labs, where they do Rust things for all the decentralized cloud storage and all of such things. Yeah, and he is going to present us with uh, exhilarating journey, a tale of implementing the Storj Rust bindings. Yeah, and he will tell us about his insights, about best practices, about strategies, and all the challenges they encountered and overcome while crafting these bindings for Storj Libuplink. Yeah. So get ready and let's go start.
Hello, everybody. Um, I am very, very happy to be here in this conference, and I hope that you are enjoying the conference. My presentation is about a tale about implementing the Storj Rust bindings as I implemented them. A little bit about me. So I am Ivan, senior software engineer working for Storj Labs. I am mostly working in Go and working in Rust in my spare time and out of my interest. Um, let's go. A disclaimer. This is my personal opinion, not the Storj ones. I'm experienced software engineer, as I said, but I need experience with Rust. So not, I would say it's not my programming language that I work every day, unfortunately. And the Rust bindings are not officially maintained by Storj. So it has been implemented by contributors. Yeah, even I am the contributor, perhaps the person that I maintain them, and I work for Storj. I usually do it my spare time and sometimes with the Storj time, but it's not in the things that we have in our product roadmap. What is Storj? Storj is a decentralized cloud storage. The benefits that Storj offers is the data is stored in multiple nodes across the globe. It's secure by default, consistently fast, the durability and availability without replication. So basically, we have data redundancy, but we don't replicate the data as it is. It's possibly I have the possibility to use the drop-in replacements with AWS S3. If you want to see a nice visual demo on how one files are uploaded and downloaded to the network and where these pieces of one file are stored in across the globe, so you can visit that URL. Storj Tech background. So Storj is a Go shop.
Go to the oh,
Sorry.
sorry, you the slides are not switching.
Oh,
So it's oh yeah, now we see.
ooh, I think it's a problem with Zoom. Okay. Yes.
Okay.
Okay. Let me know again if it happened.
Okay.
Where was the last slide that you see?
I
Was
just
this
I
one?
just have seen the first slide with the Rust
Ooh,
logo.
okay. Okay. Sorry about that. Let me see, try to refresh now. Do you see? Here it is not. Let's try. So, set. So yeah, this is the disclaimer. I think was clear. What is Storj and the benefits is about this. So I mentioned all of them. So I think you didn't miss anything. The only that thing that you miss it was the URL that I was telling you that you can visit. Let me see if now. Okay, I have a problem now because it doesn't synchronize one with my presenter. Otherwise, I will have to. Uh, sorry about that. Technical problems. It's changing now. Why is not
I
changing? Yeah, I
I
think it's
see
not
the
changing
first
now.
slide.
Uh, okay. So you should see now the first slide or the second. It's not that refreshing. Okay, I will do it with all my notes. I hope that it will be fine. I was here. Let's follow. I was saying Storj tech background. Storj is a Go shop, so everything is implemented in Go except some part of the front end. The Libuplink is the client library to use the Storj network through the native protocol, and Libuplink is implemented in Go. And after we have the Libuplink C bindings. Why the Rust bindings? Mostly is to be able to use the Storj network native protocol. And what does it mean? So if you use the Storj native protocol, it's zero trust and end-to-end connections. So it's peer-to-peer. While if you are trying to use our compatibility with S3, so you will have to go through some gateways. Obviously, your data will be decentralized and stored in the same way that using the native protocol, but the connection point is through a gateway. It's not peer-to-peer with the nodes. But yeah, that if you need that compatibility, then it's the only solution. Or that, or you run the gateway on your local. That is another possibility. So let's talk about creating the Rust bindings. Creating a Rust bindings, not these Rust bindings, just in case that you're not aware. Very minimal things. The conventions are to generate Rust code that maps to C bindings through bindgen. Bindgen is a tool that generates code from the library objects, C library objects, and the C headers. With that, so you create first crate that is called the name that you want to give to your crate. In our case, it will be Storj. So it will be Storj dash sys. And this crate, the only thing that it does is having these C headers and library objects, and then by you use bindgen to generate the code to Rust code. And after you create a second crate that is called the name that you want, the Storj in this case, and that what it has is it depends on the Storj sys as a dependency set, and it exposes the API in a safe and idiomatically way. Mostly because bindgen, what it generates, everything is are unsafe functions, and it's basically I will say a one-to-one from C to Rust, so pointers will still be pointers and all of that, and accessing to them, it will be unsafe. And you don't want to give that to your users. To your users, you want to give an idiomatic and safe API. So basically, this is a schema of mostly what you do as a best practice. Dev is great. Let's talk a little bit because it's a little bit has some peculiarities. Dev is that as a Git model, and they have a script that build a RS script that compiles the uplink-C. But Go is needed because uplink-C, even other C bindings, is implemented in Go. So in Go, you can implement C API as you could do it in Rust. So, but obviously take it doing some exporting some API that C can be mapped to C. And then, okay, you have the C objects, the C libraries, so the binary libraries, and you have to define the header, but the implementation can be in Go, and that is what is happening in uplink-C. For that's the reason why you need the Go compiler. This is an example of uplink-C generate code. So you have this struct definition in C, and then what bindgen is going to generate is this one. So as you can see, just this key that is a pointer in C is going to be transferred a pointer in Rust. So an access into this is unsafe. Things like booleans are mapped directly, and this is other structs that it will happen the same. But this is auto-generated by bindgen. The uplink crate. So uplink implementation. So we follow the best practices about documenting unsafe code. So we use all these all unsafe code are documented with the safety word or all the blocks. Yeah, and this is an example. So basically we are only wrapping the unsafe when we need it, rather than trying to wrap all the function in unsafe, because this part is safe. but this part is coming out unsafe. Well, we wrap and we document each block. And to ensure that we are documenting all the unsafe logs, we are using this Clippy rule, and that it denies us to, it throws an error if some blocks is not documented. The uplink implementation. So we, continuing with the uplink implementation, we had some we implemented some specific error type that is used consistently across all the API, public API. This guaranteed that, that everybody that use the library can, when an error is returned by the API, it's always to be of this type. And that simplifies a lot how you handle the errors, because you don't have to think. You up to this type of error that mostly is enum that implements the error trait and the display trait because it's needed. And after, with the kind of error that you get, so you can decide what to do depending on the error. So, and without doing this and returning, for example, errors that very not specific of which type of error there is, it's going to make harder you to decide what to do in case of an error. For example, an invalid argument is something that probably you will tell to the user if you are building an application that use the Storj bindings. And with the uplink, so we are wrapping all the errors that the network can return. And after here is not here is not a specific, but this is another type of error that here you have a granularity of it with error, what error you get from the uplink. If, for example, it's not found, or too many requests. So, for example, not found, you report to the user, but too many requests, you could, for example, retry. The uplink now let's talk a little bit of some Go idioms and how they were mapped to this to C and Rust. So that is important as well. This is Go code, and this is the Libuplink, so the native Go client library. Well, if you don't know Go, this is an object. It's kind of in Rust the implementation block for this type. For this type, sorry. And this is this project is an struct in Go, so it will be kind of an struct in Rust. And this is the method. This is a parameter that is used in Go. This context, nothing matters. This is creating a bucket. And after you realize that in Go, you can return multiple values. Not just one or two, you can be 3, 4, or whatever, or how many you decide. Normally you normally return 1, 2, sometimes 3. More than 3 is rare, but you could find it. More than 4, I don't know. Perhaps there is some examples, but not that many. But one idiom in Go is you always return in the last value of the function is an error. So here you return a bucket or you return an error, depending if you run one or another. And sometimes you can decide to return both. In some examples it happen. I think I have an example later. But then how you map this to C? So to mapping this to C, so first there is no methods. So we define the struct. Obviously, we define the function, and the function receive the, I will say, the object as a parameter after the name of the bucket, and after you return a struct here. Why? Because, and what is this struct? It's because you cannot return multiple values in C as Go, and we have to return a bucket on error. So that comes to this. That is what we do in Rust. What it does binding in Rust. So basically, it might directly what is in C. So it creates the unsafe function, save that, and return another struct. And this is the map to the C struct. As you see, there is the bucket and the error, just to map the two values that Go will return. And then how we are going to put this in the Storj bindings. So the best is when we map and we use a result, because in Rust for returning errors we use the result type. And here you will see that we have two values. This is because it's a specific thing in something that we have to manage in what we do in Go and how to handle this in Rust. In another situation, you will just return the result of the bucket. But in Go, what we do is if the bucket already exists, we return the bucket and an error. So we return both things. And the error indicates you that it already existed, but you get the value. And how we map this here, so we map it in a way that we don't want to return an error because the in Go is more to hint you, okay, you created a bucket, I'll let you know that exists, so but you can continue, because it's not, this function is not going to be a problem that you try to create a bucket that already exists. But I let you know that exists. So here is what we do in Rust. We map it with a tuple, telling you have the bucket and you have a bool to tell you if it was created or not. But the error part is what we handle with the result. As you see, how we can match map Go idioms to Rust in this case. After we had, we created a trait that's called insurer, that what it does is assert that the results that we are getting from the C bindings are correct. This was the easy way to detect that we are getting a bug from the uplink C. So if there is a bug in the uplink C that is returning a wrong value, that we won't know how to do it, but we know that it's not correct, then we could check every time these structs that they have two fields, the value plus the error. But for avoiding that, so to have that logic spread across all the calls, or all the calls that we do to function that return the same type. So we created this trait that is implemented in order that basically what you do, you call ensure, and if it's fine, it will return you the same value. Otherwise, it will panic. Don't panic, but don't panic. We panic because here is it's something that what you do in front of a bug that you know that is a bug in the underlying library. So our solution was to panic. If you panic, it will report to the user because this it shouldn't happen. If it happens, it's a hard error. So you panic, just stop your application. You probably will report that there is a bug, and we'll have to fix it. As I said, so this should never happen, but we ensure that the results are correct before moving forward. Like this case, so the case we implement, for example. So moving forward in terms that we are going to access to pointers, that these pointers are not going to be null. So for example, this is the implementation for the bucket result. Here, it has to be, so it cannot be both null. In this case, as I said, so can be, so they cannot be both null. So but can be one of them cannot be not null, and both cannot be not null. That is to map the pattern that I said before. So the create bucket in Go, it returns the bucket, and it can return an error saying that the bucket exists. For that reason here, they can be both not null. But in the other case, for this one, is both when there is a bug, when both are null, or when both are not null. In each other case, it's fine. And this is what the ensurer is ensuring for this type. After implemented some helpers, but this is mostly able to reduce boilerplate. For example, this was converting str, so strings, raster strings to the C strings in order to pass them to the bindings. And we, for example, wrapped this with the argument name because here we are returning a new invalid arguments that this is probably what you want to report to the user if the user is introducing, for example, the name of the bucket. Why? Because you cannot put the null bytes inside of the string, otherwise you are breaking that in C. So that probably is the only character that we cannot put in. We have other restrictions, but imagine that in bucket you could have any character. And in case of Rust, we couldn't, because we are using this, not Rust, but because we are using the C bindings, we couldn't use the null byte. So that character won't be allowed. And this is going to tell you through an error. Uplink issues. So I want to talk a little bit of issues that we found, the main ones. We find issues with Docker Rest. And sorry, Docker Rest. And you were wondering what is how do you find issues with Docker Rest? Because you document the things, you push the crate where you have to push, and everything should work. Well, yeah, that is usually what it happens. But we got an issue. So because our uplink sys is using the needs, or is using, no, but it needs the Go compiler. That means that compiling, you need Go install. Okay, but we are documenting uplink, not uplink sys. But uplink depends on uplink sys. If uplink sys doesn't compile, uplink doesn't compile. If that doesn't compile, Docker REST fails and doesn't document anything. And that is what happened. There are two possibilities how to solve this issue. So you modify the Docker, the base Docker image of the Docker REST. That's fine. It's an open source project. You can contribute, you can add it, you can send a pull request. But to be honest, I was not very keen of these changes as going to be accepted, plus the time they will take. And even if it was going to be accepted, I don't think that I like a lot that asking, to add one dependency more in a Docker image only for migrate. I guess, I don't know if there are others, but I guess that if the echo is not there, other people that found the same issue solve it in a different way. And I found the second way how to solve this. So you can adapt your crates build because Docker REST allows you to detect when Docker REST is building your crate. And after, you can add some metadata to the cargo.toml in order to specify how Docker REST is going to build your crate. Well, mostly it's in which platform, for which platforms. And how you detect that is Docker REST is building your crate. So mostly there is an env variable. That easy. Is that easy? What we did in our build.rs for the uplink sys, we built in different way for when Docker REST is building and when Docker REST is not building. When Docker REST is not building, is not building this crate. So yes, we call Go and we do what we do, what the usual do. But when it's Docker REST, what we did is adding these binary libraries into the repository, and we use directly the library binaries. That's mostly you have this here. Here we can make to build it, but here when it's doc, so basically we copy. We copy those and we join. Well, we join this as where these directories where you can find these binaries, and then everything works because mostly you need that. And after we specify it in the cargo.toml for which platform, well, which is the default platform that we are going to build. And we don't only want to build with this one. This is important because we only added the binary libraries for Linux X 8664. And you may wonder what happened with Windows. Well, Docker REST doesn't matter Windows or another platform or OS X, because in the end, you only want to build this for generating the documentation. So that's okay. Then bugs that we find during the implementation. We got bugs with CSTR and CSstring misuse. This is the diff change when we detected the problem. We don't detect it early because we were having some unit tests, but obviously it's very, very hard to detect this because in the end you are not calling the bindings because the bindings obviously call the network. And then when we started to implement integration tests, when we could, because obviously when you start with some minor implementation, you couldn't, you need to implement a little bit more things in order to be able to actually, for example, for create a bucket, you will need the bucket implementation plus the project implementation because it depends, it's a method in the project. So when we had to do the integration test, we detected this bug, and that is my fault. I recognize. Even I am trying to understand, or I read, I don't know how many times CSTR and CSstring and made some local tests in order to make sure that I understood correctly. I was misguided for my local test because it turns that I was using static strings, and though they never get released because they live, so they existed the whole life of the program. So they were never access to null pointers. But when you put here that they are not a static string is what it happened. Well, the change was to change from CSTR to CSstring in order to own the string. And And yeah, and mostly with that, we solve the problem because we're copying the string. Initially, I wanted to do it in the opposite way for performance reason, but obviously here you cannot because we have to release that. We release that from the C part in order because we don't want to drag it longer because it will be very hard to control when you have to release. And basically, we take the ownership, copying, and after we can release from C. And then we don't have a dangling pointer. Obviously, that happened because using unsafe, and is what you have to do because access into C is unsafe. Then we have back implementing the STO read, and was because of how Go as well has a reader implementation, but it works differently than in Rust. So what happened is, so in Go, when the reader finish, so you don't get a zero side. So you read zero. So you didn't read anything. You mostly return an error that is EOF. And so we had to map that. So because that shouldn't be an error in order to make the iterators work properly with the reader, because the problem was using an iterator, the iterator finished before it had to finish because we were returning in case of returning the errors. So first, when it's EOF, Go can return the EOF, but moreover, it can return you some size of data that you read, that the last one that you read. So here, what we had to do is checking if we got this error. Here, the problem is we have to check by no error because EOF is not mapped, and it's because architectural dependent. And it's the only error that is so far that we know that is not mapped to the uplink C because we cannot to make sure that it's going to be the same for all the platforms. So we cannot map it to a constant. So the unknown in this case is going to be the EOF. And then what we return is the last bytes that we read. And then this iterator in Rust won't finish because it won't return zero, but it will call again. And the next call, it will return the error again, the same error in Go, but the 0 bytes. And then is when we return zero, and here the iterator will finish and the reader in Rust will finish. If there is another error, obviously we return an error. And when there is no, and when in case that here, so we, I don't know why it's here now. In case that here, so when we read bytes that is different than zero, we return okay with the size. And you can see here that there is a retry. Sorry, that's because of the scroll. And this happened because it could be, this is how our network works. Sometimes it can return zero, but not EOF. That means that, okay, you didn't get any data, but we didn't return EOF doesn't mean that you finished. So you have to call it again. And this is only happening in some situations, and I'm going to explain the architecture of the network. But mostly with one core mole, what you call again, and you get the next chunk of data. So here with only one iteration more, it should be fine. But just in case I added three, it's three retiles, so it's not that hard. It's not that much. If then this won't happen, then in the end you will return the last bytes. Sorry, you return zero, but you didn't return anything because the network in the end didn't return anything. And once we did that, so the iterators work properly. Project highlights. The project is in that GitHub repository. It's complete and up to date. Has tests, unit tests, and integration tests. We have a Docker Compose that it runs a local network with nodes and satellites. Well, satellites is now metadata server and everything that you need to interact with the network in local. And that is what we use for the integration tests. Well, we use as a CI GitHub Actions. Well, we run all these tests plus linters. We have good comics, so use a prefix. The commit messages are, I will say, quite thorough. So they display how and why we are doing the changes, and moreover, when every commit is every commit pass the test, so you don't depend on other commits. And it's full well documented. So we use this linter rule to ensure that everything public is documented. Yeah, and well, there is more room for more improvements for sure. Feel free to contribute if you wish. Yeah, that's all. Then here questions. If you want to access to the slides, so you can access in these two URLs, just web format and just a PDF. Yeah. So questions.
So yeah, can you please display the last slide? I see black screen. Yeah.
Yeah, sorry. This is because I opened let me close. This is Zoom in
Oh,
Linux. When I open
uh,
another window, it's stop sharing. That's okay.
okay.
You will have to read the questions then.
Okay, I will read the questions. Yeah, Q&A. One question for now. What else does the uplink rate needs improved so people may know if they can contribute right now?
Well, the uplink Cs, so the C bindings now are only available for Linux and OS X. And it's not a matter that the C bindings cannot be compiled in Windows, actually, because uplink C, you can compile it in Windows. It's a matter that we have to change the build script to be agnostic to the operative system. So now we are using operative system commands like copy, move, or whatever. And obviously, we should use some crate. I cannot remember the name, but there is a crate that allows you to call these copy files and this is going to map to if it's Windows, Linux, OS X, and you don't have to worry about it. Actually, we had a contribution for it, and it was a pull request and we were sorting out on a few things. But then when I said, okay, the thing is fine, the only thing is we have to change this, the contributor said that he was not more interested because he wanted to use a sync. And obviously our API is not a sync. And perhaps now you may wonder why we don't expose an async API, because obviously this is a lot of network calls. Mostly because I think, so I am not an expert on this, but if we may take a sync, we are not going to take any, first the effort, obviously, that we haven't made it, but doing in a sync is not going to do any benefit because at the end, we have to call the C. And C is not going to sync in how it works in Rust. So in the end, there will be blocking. We put an async layer, but if it's blocking what you are calling below, there is no benefit. And yeah, he lost the interest and the thing is there. And for me, perhaps it was pending to do it on my own, but I haven't done it. This is one thing that mainly thing that I am thinking that is a stopper. The best thing will be perhaps implementing everything in Rust rather than use the C bindings. But yeah, that's totally another story.
Yeah, thank you for the answer. I see no questions yet. So if any of participants want to ask a question, better do it right now. Well, I assume there is no more questions. Oh, there is question. I see. Yeah, but I asked it. Yeah, the question, what else the uplink needs improved? So,
Yeah, it's what I mentioned. So I think I have there are some issues open there, not very important. I think some of them were another thing, for example, it's something that I opened, but the thing is, because I was not the creator of the uplink sys, I wanted always to confirm with who created the uplink sys. I only improved it a little bit. For example, when we add integration test, because uplink sys in the end, it did have an integration test, but it was using the real network, and that is not good because for running, you have to create an account and all of that. So when I put integration test in the uplink, I use the same integration test for uplink sys using the local network. But I didn't decide, for example, there are one thing. I don't like that uplink sys depends on Go. I am a Go developer. I have Go compiler, but it doesn't. The most of the Rust developers that they don't use Go, so they won't have Go installed. And when you want to use a crate and you add it as a dependency, and then you realize that you have to install Go, it seems a little bit wrong to me. I know that the arguments are how we do, so we can add all the all the lib binaries for each platform. We can download from internet. Now they are available. At that time, they weren't available, so we can download. And they said this is not very flexible. So, and I said, well, we can. I think the conversation in that issue is about we can do both things. So we can try to compile it if you can go, for example. If you don't have it, try to download them. Yeah, that, for example, will be a solution. And obviously, if we don't have on a specific platform, obviously we fail. We try to Go, but if you don't have Go, you don't have a binary for the binary library for the specific platform, let's say, I don't know, FreeBSD. Then obviously you have to install Go and compile it in yourself. But if we cover the three main operating systems and architectures, that should be, for example, an improvement. But the conversation is stuck there. The thing is, I don't dedicate that much time on it now because there is not that much improvement, and I haven't. I don't know if many people are using. So I only got this contribution, and some people like the project, but I think mostly or clients now are more companies, and they use the S3, for example, gateway, so they don't need the native bindings. But and then they dedicate not much time that only the things that I dedicated has been updated to the last updates of the library. So basically, when we have a new version of the LNC is when I try to update it in the next couple of weeks.
Yeah, okay. So we now have more questions. And yeah, what is the difference between S3 and Storj?
If you ask me in general about the network, so in S3, you store the data in one data center. I know Amazon is going to replicate or make some redundancy that you are not going to lose your data if one disk fail, obviously. But in the end, you are located in one data center. And that means that if there is a natural disaster in that zone and that data center disappears from the map, so your data disappears from the map. So this in our case doesn't happen because we have nodes across the globe. And if we lose some nodes, it's fine. So our redundancy is configurable, but I can tell we can, for example, we store 80 pieces. So we break your file or your data in 80 pieces. We store these 80 pieces in 80 nodes, different nodes, and spread across the globe. Then with only 29 pieces, we can reconstruct the data. That means that if 51 nodes disappear from the globe, we are still being able to get your data. And 51 nodes spread across the world is difficult that they disappear. And so that's the redundancy. In Amazon, just probably you can replicate your data across the data centers. But obviously you are replicated to 1, 2, 3, 4, as many as you want. But every time that you replicate your data, that's a cost. And our cost is lower than Amazon without any replication. And moreover, because we are distributed across the globe, the access to the data is very, very fast. In Amazon, if you are next to the, I will say, or very close to the data center, it's going to be faster than us. But if you are in another part, the most of our use cases for from some average size of files, we are faster downloading because we are downloading from the nodes directly. What happened? Then let's talk about why we have an S3 gateway and why we use the S3 protocol.
We have lots of other questions.
Okay. Yeah, I don't know. I didn't know if that question refers to one to another.
Yeah. So there are 5 more questions. Yes.
Okay. Let's go with them.
Okay. Is there any progress towards safe bingens in Rust? Is it even possible technically? I can imagine that there are some widespread patterns among all bingens that could be safely abstracted.
Sorry, I don't get the question then. What's the question specifically?
Is there any, is let me rephrase. Is it possible to write a safe bindgen, something like that, so that it creates safe bindings from unsafe language?
No. So obviously the wrapper, so you could go and directly take C and do a safe wrapper and not use bindgen. But so bindgen is not going to do anything bad. What it's going to do is facilitate you how to access to C. But obviously it's not doing any safe. It's the same that you access to C. So the safety is on the crate that wrap the underlying C library in a safe Rust.
Okay, what are the key features and benefits of Storj compared to other storage solutions? I think you kind of answered the question comparing with S3. So,
Mm.
what does the Boolean value in the result of create bucket mean?
Yeah, that is the thing. So um, well, I don't want to, but if you go to the Libuplink, so the Go implementation, the create bucket method returns a bucket and an error. And then it says, if the bucket, when you create a bucket, if the bucket exists, you will get the bucket, but you will get an error. And the error is that the bucket exists. So we wanted to do to reproduce the same in Rust because in Go, when you do that, you can ignore the error unless that you intentionally want to do something. So say, okay, if the bucket exists, it's because I have a bug in my library or whatever, and I want to notify it. But otherwise, creating a bucket is a no-op operation, and you can continue doing what you want to do. For example, imagine you create a bucket, and after you copy data. If the bucket exists, it will return you that error, but say, okay, if the error is, I get the bucket, but if the error is because it already exists, it's fine. Just continue and copy the data. And then the way that is what the Boolean says. So you get the create bucket and you get the bucket and true is that the bucket was created. But if you get the bucket and false, you get the bucket and you know that it was not created at that time because it already exists. And I didn't want to return an error because, as I said, probably how you're going to handle errors in Rust. So mostly when you get an error is an error, no? I would say, and how you I feel much better to have an Boolean for that specific case than having an error that saying the bucket exists. And no, sorry, totally wrong. So to reproduce the same behavior of returning an error and a bucket, you cannot do that in Rust because in an result type, or you return one or another, but not can return both. And that is how I map. So okay, for that case, you can a Boolean indicated that specific idiom in Go.
Okay, so what other possible issues or bugs may appear with such trust on binding? So like maybe memory leaks or double freeze, something like that.
Yeah. Um, so yeah, if there is a double free, for example, will be in the uplink, not in the uplink sys, because how the C bindings are implemented is that they have methods for free every type, but you have to call them because in C you have to handle that. And I um so I thought to let's implement drop, but you cannot implement drop in uplink because the uplinks because these C so the uplink C types are in another crate and the drop is another crate. You cannot do that in Rust, so you have to do one or another in your crate to be local. Otherwise, you cannot do it. So I discarded to the drop and I have to call the free whenever I need. Obviously, it could be a bug that is unsafe because calling free is a FFI function that I have to call it with block with an unsafe block. For that reason, they are documented and trying obviously what. So and try to document those blocks and who is reviewing should be careful to review that part because that is unsafe and put a lot of attention on it. There is another solution that some person told me when I gave this talk in a meetup, and it was to wrap every type of the uplink Cs in another stroke and implement the drop for another stroke. and then not to deal with the free calls directly and rely on drop. Yeah, that's a nice solution, to be honest. I didn't think on it in that moment, so it was an idea that it was but now changing everything, yeah, I could do it, but so far I haven't found any error with the test that we had. We found some of them. It was I don't remember, but it was during the integration test that we have. But with integration test that we have, that I think it almost cover all of the network functionalities, we haven't found the issue. But obviously it could happen. So that will be a bug and we have to fix it.
Okay, and the last question. Did you have problems with creating bindings to functions that may return the default values? Like in Go functions can return null, and what should they return in Rust, for example?
Well, that's an example of, for example, in Go, they say the create bucket. You return the bucket on the error. When there is no error, that is a null. How is that mapped to C? Is the struct that it has two fields, and the two fields are, well, that error, it will be a pointer, and that pointer will be nil, so we will null too. So what we check is that. So that is in the unsafe part, and we check that we have to check if that pointer is null or not null before doing anything. So basically, when it's not null, we know that there is no error, and then we don't map. And what is when it's not null is an error, and we have to map it to the specific error type in the Rust part that we implemented. So in the error type that we implemented.
Okay, I see no new questions. Yeah, I really thank you very much for for participating uh, in our conference. Your talk was really good and pretty interesting. And yeah, I wish you a good luck and thank you everybody who attended the talk about
Thank you very
Storj.
much, and thank you for having me in the conference. I hope that you enjoyed it.